Okay, so this is our third video of our adding vectors set, and this one is using cosine law and sine law. We're going to add the same two vectors that we did in the component method question, and here we're going to do them with cosine law and sine law to show that they should give you the same result. So our first vector is 30 degrees north of east, and it's 4 meters. So we'll draw the first vector nice and big. So we have 4 meters, and it's 30 degrees north of east, and that's vector A. Vector B is 3 meters, 20 degrees east of south. So second vector cuts back that way. This is vector B, 3 meters, and it is 20 degrees east of south. So our resultant vector, I think I switched my colors up here, my mistake, but our resultant vector goes from the beginning of A to the end of B. So that's our value of R. We want to be able to figure out the magnitude and direction of that vector. So if we make a right angle triangle based off of vector A, we come up with the fact that this angle up here should be 60 degrees to make the right angle triangle, or if you use Z law, you get 30 up there, giving you 60 inside. That tells us that we have 80 degrees as our angle opposite to the resultant, and that's what we need for our cosine law calculation. So to do our cosine law calculation, we're going to say that R squared is equal to A squared plus B squared minus 2AB cos, and we've been calling it R, but it's usually cos C, which is the angle that's opposite the resultant. So here, R squared is equal to 4 squared plus 3 squared minus 2 times 4 times 3 times cos of 80 degrees. And so we can work out a value from that for R. So 4 squared plus 3 squared minus 2 times 4 times 3 times cos 80, and then square root our answer, and we get 4.56 meters. Now to get the resultant angle, we have to come back to our drawing here. What we need to be able to do is figure out this angle right here that goes to the horizontal, and that will be our angle theta. But in order to do that, we need to figure out this angle here, this big sweep that is opposite of B. So I'm going to call that little b, lowercase b, for our sine law calculation. And then we'll just have to subtract 30 degrees off of that angle to get our bearing. So remember that sine of this angle B that we're trying to solve divided by its opposite side, 3 meters, equals sine of 80 degrees divided by our resultant R. So you're always using the angle you used in your cosine law calculation and the resultant value you got as one set of things. Then you want to find one of the other angles and use its opposite side to get it, right? So here, sine of 80 times 3 divided by 4.56, and then we do inverse sine of that, and we get 40.38 degrees. So our angle theta, right, so this angle B is 40.38 degrees. We want to solve this part that's there. So theta is 40.38 degrees minus 30 degrees from the question originally, and you're left with 10.4 degrees at a bearing that is south of east. And that matches up to what we had in the previous question.